algebra students, this lesson is going to be our first lesson of 3 on something called an inequality. In this lesson, we're going to be talking about how you graph inequalities, and then the second part will be how you solve inequalities. So as you're reading this, you might be asking yourself, do I know what an inequality is? Do I remember what they look like? Do I know anything about inequalities? That'll be where we start this lesson. So to answer the question, so what is an inequality? An inequality comes from the word unequal. An inequality is just going to be a statement that compares two unequal amounts. So the first 3 lessons in this unit were on equations. Equations are stuff like 2 + 2 = 4. Equations talk about things that are equal. But if we're talking about something that's unequal, that's where we would use something called an inequality. Now, because inequalities are literally unequal amounts, we can't use an equal sign. Instead, we have 4 symbols we use that make up our 4 options of inequality symbols. Our first symbol is for less than. I would use this symbol here if I wanted to say something is less than something else. Greater than goes the opposite direction, so greater than would look like this. You can also say less than or equal to. That's similar to this sign. So we've got our less than, and then you put that line there to mean the or equal to part. So it's kind of like combining this symbol with an equal sign. And then our last one for greater than or equal to, we've got greater than or equal to. So these are the 4 symbols we're going to see in our problems today. The first thing I want to do to help us practice with these inequality signs, if it's just been a while since you've seen them, is decide what inequality sign is going to go between these 2 problems. Go ahead, this first one, which inequality sign would you want to use? We want it to say -2 is less than 5. What about the second one? The second one is usually the one that's a little trickier for students. It would be -7 is greater than -10. Sometimes that's confusing for students because we know 7 is less than 10, so why would -7 be greater than -10? There's a couple ways you can think about it. You can think about it on a number line. Greater numbers are always this way, so if you compare 10 and 7, 10 is further to the right. The same thing is true with this statement. -7 would be further this way than -10, so -7 is greater. You can also think about it with temperature. -7 degrees is higher or greater than -10 degrees. You can think about it with money. If your bank account said -$7, technically that's more than having it say -$10 because it's less debt. Whichever way makes sense to you. But you do want to make sure you can look at 2 integers and know which one's greater and which one's less. Where we're going to start is looking at inequality problems with variables in them now. So for example, something like this says b, which remember variables represent a number. So what this is telling me is b is a number that is less than 2. Just based off of that description, b is a number less than 2. What numbers am I talking about? Any number less than 2. It's like 1, 0, negatives, all those numbers on this side. One thing you could be asked to do is graph these. I wanted to graph b is less than 2. I want to start by going to the 2. Because 2 is not less than 2, we use a circle like this. We call this an open circle, meaning that I'm not including 2 in my answer. And then I want to shade all the numbers that are less than 2. These are all the numbers less than 2, so I would be shading this direction. You can do a wiggly line like that, you can just color it in like this, but this is showing that these are all the numbers that are less than 2, and I've got an open circle because 2 is not less than 2. If I had asked you to graph b as less than or equal to 2, it would look really similar to this. The only difference is this would be colored in to say that 2 is a number that is less than or equal to 2. Got one other example, and that is this one here. This one says -3 is less than or equal to x. Now this one's written a little different than number one. This one has the variable come at the end. Sometimes it's harder for students to figure out what this means when you've got the variable at the end. Saying -3 is less than or equal to a number, it helps when you flip it around. Now when you flip inequalities around, like 2 is less than 3, when we flip it around like this, that inequality sign needs to change. 2 is less than 3, but 3 is greater than 2. So if I wanted to flip this around so that my variable came first, it would say x is greater than or equal to -3. I personally think this is easier to think about. Instead of this first one, this is just saying x is any number that's greater than or equal to -3. So my tip or my advice is it helps to have that variable on the left. So if we're saying x is a number greater than or equal to -3, first thing we want to do, just like before, is find -3 on our number line. This number line's missing some numbers, so just be careful. -3 is right here between -2 and -4. And then because it's got that or equal to sign, I want to say x could be -3. We show that by coloring it in. This right here we call a closed circle. Open means it's not colored in, closed means it is colored in. So we've got x is equal to -3. Now I want to show that x is a number greater than -3. Anything greater than a negative, I said that weird. Positives are always going to be greater than a negative, so that's one way to know that it's going to be shaded this way. -2 is greater, -1 is greater, 0 is greater, all these positive numbers are greater, so I would shade this direction. I'm going to have you try these next two here. First for number 3, you tell me, would we want an open circle or a closed circle at -1? You want closed because we've got it's or equal to -1. So this is showing that m could be -1. What about the shading? We want to show this. Which direction would we want to shade? Left or right? We want to go right. This says m is greater than or equal to -1. M is greater would be all these numbers here. These are all the numbers that are greater than -1. One last one for 4. Go ahead and describe for me what this graph would look like. All right. Something you could do to help you out is, since the variable's at the end, let's flip it around like we did in this one. Let's say x is greater than -4. That makes it easier to see. I would want an open circle on -4, and I would want to shade the numbers that are greater, which would be this direction. This is the first part on graphing inequalities. Hopefully this gives you a better idea of what inequalities are. The second part of these is going to be on solving. But before we do that, just a quick summary of what we noticed in these. The first part is you are always going to be shading to the left, this direction, if you're talking about the less than sign or the less than or equal to sign, right? If I say x is less than 1, I would shade to the left for that because those are all the numbers that are less. You'd be shading all the numbers to the right for greater than or equal to. What about a closed circle? A closed circle looks like this, and you would want to use that for our less than or equal to sign or a greater than or equal to sign. Closed circles are showing that it could equal the number. So if it's got an or equal to part, you would only use a closed circle. And the last one, open circle, it's the opposite. Open circle is open, it's not colored in, and you would be using that if it doesn't have the or equal to, because this is showing it can't equal that number you put the circle on. So this is a quick summary. You might want to include this in your notes. All right, so now the part I mentioned before. The second part of this is going to be on how you solve inequalities. So again, I like this idea of comparing it to something you already know. You already know how to solve equations. Let's see how it compares to solving an inequality. Go ahead and solve this equation for me. All right, how'd you do? Well, we want to start by distributing. So I would say 5 times x is 5x, minus 5 times 7 is 35, and gives us our 20. Next, you would want to add your constant, which is 35 on both sides. Negative 35 plus 35 gives me 0. And that leaves us with 5x equals 55. That last step is dividing by 5. 5 divided by 5 gives you 1. 1x is the same thing as x. And 55 divided by 5 is 11. So we get x equals 11. We had mentioned this in a previous video, but when we say x equals 11, what does that mean? What does this solution mean for this equation? Well, it means if you were to replace x with 11 in this equation, you'd get something that's true. The only number I could put here for x is the number 11. If you do that, 5 times 11 minus 7 equals 20. It's the only number that works there to give you 20. It would give you 5 times 4, and then it would give you 20 equals 20. So what this solution means is x can only be one number, and that one number is the number 11. Now we said in this part we're focusing on solving inequalities. I know you haven't seen it yet, at least with me. Go ahead and try solving this inequality. Well, I asked you to try because it's going to use the exact same steps as your equations, which you already know how to do. Just like the equation, we would start by distributing that 5. Just like the equation, you would add your constant on both sides. Just like your equation, you would divide 5 on both sides. The only difference is what sign is between that x and 11. Here we were saying x equals 11, but for this problem we're saying x is greater than 11. I want to pause here and just emphasize you are using the same steps. I've had a lot of students over the past years come in and know how to solve equations beautifully. They're like pros at it. And then you give them something like this and they're like, I've never seen that before. I don't know how to do that. You do. It's the exact same steps. So if you were feeling really good about solving equations, you should feel really good about solving inequalities because it's the same thing. Really, the difference between these two comes down to what these solutions mean. When we say x equals 11, we already said x can only be one number. That one number is 11. That is the only number that works in our original problem, so that that left side equals 20. What do you think this solution means? Well, when we read it, it says x is a number that is greater than 11. What that solution means is that x right here, you can replace it with any number greater than 11, and it would give you a left side that is greater than 20. So for example, I could pick the number 12. 12 is greater than 11, right? I could put 12 right there, and this left side should be greater than 20. This left side would say 5 times 5 is greater than 20, so we get 25 is greater than 20. That's true. Now I chose 12 for mine, but you could choose any number that's greater than 11. You could choose 15, 100, 1,000. You could choose 11.5 because 11.5 is greater than 11. You could pick fractions that are greater than 11. There are tons and tons of numbers you could replace x with to give you a left side that is greater than 20, just like our inequality says. So when it comes to the solving is very similar. But when it comes to what the solution means, they mean really different things. Here, this is saying that x can be any number larger than 11. If I asked you how many numbers is that? How many numbers are larger than 11? Usually the answer I get in class is a lot. The mathematical way to say a lot is x can be infinitely many different numbers. Infinitely many is that math way of saying a lot. So I really want you to know not just how to solve them, but what the difference in the answers is. Equations mean x can only be one number. Inequalities means your variable can be tons of different options, which is why when we were graphing them earlier, we're shading that in just to show that x could be any of those numbers. There's so many options for it to be. Now that we've talked about how they're similar, there is one thing that is different about solving inequalities. The one way that solving inequalities is different than equations is there's an extra thing you have to remember. And that extra thing, I'm going the wrong way. That extra thing is if you multiply or divide by a negative or a negative number, you must flip the inequality sign. What I mean by that, let me finish it. Inequality sign. What I mean by that is if you were to have negative 2x is greater than 8. When you go to solve this, you would have to divide by a negative. I'm dividing by a negative, so I have to flip the inequality sign. I just have to change the direction it goes. So for my answer, instead of being a greater than sign, it would be a less than sign. Now over here I've got the question, why does that make sense? Why are we flipping inequality signs? It's more than just a rule. There's a reason why. And to help you see the reason why, let's just go back to numbers. Forget the variables for a second, just think about numbers. If I pick any two numbers, let's pick 4 and negative 3. If I wanted an inequality sign between the two of these, I would want to say 4 is greater than negative 3. You agree? Well, let's do this. Let's multiply or divide by a negative. Doesn't matter what you do. I'm going to choose multiply, and I'm going to multiply by a negative 2. So let me come in here. I'm going to multiply both sides by negative 2. I'm going to multiply both sides by negative 2. What does that leave us? Before, remember, I had 4 is greater than negative 3. After I multiply by negative 2, on this side I've got a negative 8, and on this side I've got a positive 6. What inequality sign would I want here? Well, in order for what I just wrote to make sense, we would need that inequality sign to flip. I would want it to say negative 8 is less than 6. Negatives are always going to be less than positives. So this is just like one quick example to show why when you're doing that, when you're multiplying or dividing by a negative, that inequality sign would flip. If you don't believe me, try more. Make up little problems for yourself and multiply or divide by a negative. You'll see you always need to flip the sign for it to be true. Now if we had done that same problem, but I had done a positive, like that, I wouldn't need to flip the inequality sign. It would stay the same. So that's where this negative part comes in. It is only when you multiply or divide by a negative that you need to flip the inequality sign. If you're multiplying or dividing by a positive, it's going to stay the same. If you're adding or subtracting, it's going to stay the same. It's only this right here. So keeping that in mind, we're going to look at 2 examples of this. So we've got the first one over here. It says negative 24m plus 4 times 2 plus m is less than 28. Go ahead, what do you think the first line is going to be? Well, the first thing you would want to do is distribute that 4. So we get negative 24m plus 8 plus 4m is less than 28. There's a couple things you could do next, right? You could subtract your 8 on both sides. I personally like the idea of let's combine like terms next. So I'm going to come in and say, I'm going to combine this and this. Make sure you're being careful with the signs in front of those numbers. A negative 24 plus 4, different signs means I'm subtracting and keeping our negative. So we get negative 20m. Need to copy down my plus 8, and then it's still less and 28. Next thing we want to do? Well, I've got my constant here, so I'm going to come in and subtract my constant, subtract 8 on both sides. That's going to leave me with negative 20m is less than 20. There's one step left. What do you think our answer is going to be after we do this last step? Well, the last step is we need to come in and divide both sides by that negative 20. I'm going to come in and say divide by negative 20, divide by negative 20. On our left side, negative 20 divided by negative 20 gives you 1. 1m is the same thing as m. On our right side, 20 divided by negative 20. 20 divided by 20 is 1. Positive divided by negative is negative. What's going to go between them? Well, we divided by a negative. Remember, we just said if you multiply or divide by a negative number, that inequality sign needs to change. Did you say m is greater than negative 1? I hope so. If not, my advice, write yourself a little note. Why did that change? We could say I'm going to use the word flip. We flipped the inequality because why? Because we divided by a negative. Help future you know why we did that, why we changed that inequality sign there. All right, there's one last example to look at. We've got negative 4z plus 3 is greater than 9 minus 5z. The question is saying which number is a solution for the inequality below. In order to answer that question, it's going to help us if we solve it first so we can see what z is. Again, there's a couple different ways you can do this. One of the steps you're going to need to do though, you've got z's on both sides. You don't want it on both sides, you only want it on one side. So you could cancel your negative 4z, you could cancel your negative 5z, doesn't matter which way you do it. I'm going to start over here though. I'm going to say plus 5z, plus 5z. You could add 4z on both sides, but the reason I chose this one, do you know why? I chose to add 5z because over here, if I do that, negative 4 plus 5 leaves me with 1z or z. Means I don't have a number there I have to worry about. Z's already by itself. You did negative 5z, if you added 4z on both sides, that would give you a negative z. So, just a little trick. Either way you do it though, you end up with the same answer. If I'm adding 5z on both sides, here I get z, I'm going to copy my plus 3, and then is greater than 9. There's one last step. Go ahead, finish solving this inequality, and then choose for me which number is a solution. Is it 4, 5, 6, or 7? Well, let's see. If you finish solving this, you get minus 3, so z is greater than 6. And I can tell you, I've done this problem a lot in class, and the majority of the time people say, okay, z is greater than 6, 6, done. Not done. It goes back to how you read this, right? What does this mean? This means that z is a number, z is any number, that is greater than 6. The question is asking which one of these is a solution. Another way of saying that is which one of these numbers could z be? Well, if z is a number greater than 6, could z be 4? No, because 4 isn't greater than 6. Could it be 5? No, because 5 isn't greater than 6. See where I'm going with this? Could it be 6? No, because 6 is not greater than 6. If I say I'm thinking of a number that's greater than 6, my number can't be 6. The only option z could be is 7. Tricky, I know. But part of the reason for this question is to see, do you understand what this means? Right, if this was an equation and we got z equals 6, well then yeah, it's 6. But because it says z is greater than 6, we have to really think through what that means. Now one bonus question, what if we had gotten z is greater than or equal to 6? What would we say then? Well, if z is greater than or equal to 6, for this one, z could be 6, because it's saying z is a number that's greater than 6 or equal to 6. So it would be 6, and it also would be 7. So if this had been the problem, our answer would have been Z. It would have been C and D. This one though, the only option it could be is D. Fun question. I'm gonna go ahead and erase all this, and then there's gonna be one for you to try. Your problem looks like this. Which of the following is a solution to 4 minus 6 times the quantity 1 plus 3x is greater than negative 20? Go ahead and try that. All right. When you go to do this problem, sometimes students want to subtract these. You can't do that. You've got to do your multiplication first. So I would copy my 4. Negative 6 times 1 is negative 6. Negative 6 times 3x is negative 18x. Be careful with that negative sign. That is greater than negative 20. We could then say 4 minus 6 is negative 2. Minus 18x is greater than negative 20. I could add 2 on both sides. That gives me negative 18x is greater than negative 18. Last step is dividing both sides by negative 18. That gives me x. Now because I divided by a negative, I want to change my inequality sign. So we get this as our answer. Just like that last one we did, it's asking which one of these is a possible solution. Well, if x is less than 1, the only option here that is less than 1 would be option A, the negative 4. I hope you got that right, or if you didn't get it right, I hope that that makes sense. Just another reminder, we have virtual tutoring every day, Monday through Thursday. Please feel free to join if any of these lessons don't make sense. You can also sign up for in-person tutoring on Friday, and we would love to see your faces. All good options. There's one last one for you to try. This is putting everything we talked about in this lesson together. So the first part is solving this inequality. Once you've solved the inequality, we're gonna have you graph the solution. Then after you graph the solution, I've got like a quick little check to see, do you understand what that solution means? So the first part, go ahead and solve the inequality. After you've solved it, go ahead, I know you don't have a graph on the computer to use, but go ahead and describe what that graph would look like. Make sure to mention, is it gonna use an open or a closed circle, and mention which way the shading is. All right. And then the last one is based on all of this, I'm asking you, is D equal 3 a solution for this inequality? Go ahead and tell me yes or no, and make sure you explain why. So if you say yes it is, you say yes it is because, or no it's not because, explain how you figured it out. All right, thank you so much for watching this lesson. Hopefully you're feeling a little bit better about inequalities. We're going to use the information we talked about in this lesson a lot for tomorrow's lesson, because we're going to be building on what you know about inequalities. See you tomorrow. Thanks. Bye.